Hello everyone, my name is John. Today I'm gonna present about the operating system security in the healthcare systems for the final project presentation. So this is the agenda for today's presentation. Firstly, I'm gonna introduce the importance of operating system in healthcare area as well as the security challenges. And then the regulatory compliance framework gonna be presented in general. And then the healthcare operation system architecture, which is the proposed solution for a comprehensive methodology. Finally, we're gonna give some discussion and future work for the matter. First of all, the healthcare operation system is crucial because it monitors the important patient data and health applications. There's several security challenges to the operating system regarding to the healthcare system, including the outdated system, malware, ransomware, unauthorized access, and data breaches as well. That's the reason why the operating system security in the healthcare system is very important to ensure the patient privacy, to monitor the compliance, as well as sustain the system performance. These are the regulatory compliance framework for Canada regarding to personal information protection and electronic document act, or PIPD PEDA. So according to the PPD, it is mandatory for all organizations regarding to the healthcare to protect the patient information, get the patient consent for the collecting, using, and distributing, as well as protecting their patient's personal information. It is also compulsory for them to deploy the security measure to protect patient data from breaching, leaking, or damaging. Additionally, they have to build the responding procedure in case of data privacy compromising, and must inform the affected patient as well as the authorities immediately. Based on the requirement, a proposed solution for the healthcare operation system architecture is proposed as below feature. So as you can see, so there are several layers of protection in the OS level security. So first of all, a user space security server will be created and monitor the flagrant usage control decision. The user space security server will be single gate to verify any access to the patient document. If any application is not security server, it will be denied immediately. The security server will update the subject and object attribute whenever accessing object based on the user control model, which enforces the policy check. There is also an attribute repository where the security server store all user and object attribute corresponding to their patient document. When there is a document access request, the viewer application will trigger a submission intention to the security server. Security server immediately fetch the corresponding usage policy from the policy management server and then conduct the attribute checking as well as the condition verifying with the policy provided the access or deny decision on that document. Based on the domain-specific knowledge of the security server, if you confine the user with their domain of role, for instance, it only allow the physicians to write, edit, or add physician to patient document, while other user can only read or not able to read or write. based on their role. There is also a gateway setting as document provider interface, which is controlled by the kernel policy. When a document is sent to gateway interface, it will be separated into data and policy. Once it's done and pass checking, the document is available for use. The next layer of data protection is under the kernel's policy. This is an enhancement of security mechanism to ensure data in rest, which is stored in this storage or device, is not breached. The access line is chosen to confine the access rule to fine-grained objects, which certain applications are allowed to access for patient data. In this architecture, system will allow only security servers to the patient record, while others will be denied. So this is the overall data protection with different layers from the healthcare operating system architecture. With this proposed solution, we can see that this is the lowest level, which is the operating system level of security, supported by the SE Linux for enforcing the policy from both kernel and user side. The advantages of this architecture include multiple layer protection to protect data with the authorized access control. The future work and solution can be included with the below suggestion to have a comprehensive approach for a secure healthcare operating system. First of all, we need more patching and updating operating system in order to fix the bug, vulnerability, and compatibility issue as well. By frequent patching and updating operating system, we can prevent those data from outdated and improve the system performance. Next, another method to enhance the healthcare operating system is to encrypt patient data and information. It's the process of transforming data into unreadable format with a secret encryption key. Data can be accessed with the correct key from authorized user only. So it is recommended to use strong encryption algorithm like the AES for the better security. And then we need more monitoring and auditing the operating system frequently to collect and analyze data for the OS performance, data, and behavior. Monitoring and auditing is helping early detection on security issue and fix it on time. And finally, we need to educate and train the user for the secure operating system in the healthcare sector by providing information and guidelines how to sustain and provide the healthcare operating system. It will strengthen the compliance and prevent the human error, which may lead to the data security incident. A good healthcare system will be maintained by users with full knowledge and awareness of patient privacy for their personal data. With that, these are the references used for the report. Thank you for your listening.